Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, an all-around nice guy, meteorologist DT from weatherist.com, the Colonel of Confusion, the Captain of Catastrophe, the Commander of Chaos. It's 5 o'clock here in the East, 2 o'clock West Coast time. Let's talk about this week in weather across North America. And this particular edition, I'm going to be spending some time talking about the false alert or non-event coming up that some of the models were showing for November 13th and 14th. We'll be talking about why that did not work out and the difference between that and the East Coast upper air patterns, which are very important, and also the second half of November. So lots to talk about. Let's get right to it. All right, first we'll do, like I said, the November 13th and 14th event. Now, this is the GFS model, if you recall, that this is from November 6th, so this was a few days ago. And this is the model run which got everybody excited and while the Weather Channel was talking about the crippling snowstorm. So let me point some things out here. First, you can see the date right there, November 6th, right? And this side, of course, is from Tropical Tidbits and Levi Cohen, who makes absolutely fabulous maps here, and very clean, very easy to see. And we can see the big area of low pressure here. Look at all the heavy snow in this area like this. So, and look at the gargantuan high here and here. It's a great looking snowstorm map, but the problem is the upper air maps were a little off. The next run of the GFS was for November 7th. This is the 12 hours later. And we can see, again, this is showing a little bit more rain on the coast and a mountain snow inland, which if it was going to happen would probably happen this way. But again, this is the runs that got everybody excited. Now, what happened here is that the GFS was now developing the upper low over Kentucky. You see there, earlier it had it here, which is why it was all snow for the mid-Atlantic states. That's why we had the inland run here with the rain coming in and the snow, because the upper low is now over Kentucky right there. So that was one of the differences with the GFS, but it was showing a big storm. That was the important thing. Now, the European model was the first reluctant to do that. Then the European model got involved in it. Now, this is the European model here from November 7th. This is the 0Z run. Let me point out some useful features here. First, we have the upper low right here. You can see there was a low here, and we have a bit of a ridge this way. See that? Okay, so the flow is coming down like this, and we have another upper low here over southeastern Canada. Okay, and what was happening is that there was a piece of energy right here which comes down and becomes an upper low right over here, and that develops a storm. And that's what the European was doing here. Now, that's the upper air model of the European. There are several problems with this. For one thing, the Pacific is terrible. Look at the flow coming in for the Pacific. It's very strong. It's very fast. And the problem here is that this amount of energy could act as a kicker. So typically what you want to have is you want to have a ridge on the west coast of some type, Western Canada, some sort of ridge on the west coast like this. And instead what we have is a lot of flow coming in here. And that was a problem with the overall solution. Also, we have there's a positive NAO here, as you can see as well, and we also have a positive Arctic oscillation. And I've said this to you many times before, you don't get snowstorms simply by having a big L on the weather map. You have to have these features in place first, and we didn't have them, which is why I was so skeptical of it. Now, this was the 18Z GFS that came out also, I believe it was on the 6th, and this got everybody all excited. The Weather Channel was freaking out. And I made this up on the Facebook page, so you can see you don't get East Coast storms simply because the weather model happens to have, let me see if I can enlarge this a little bit here. Oops, too large. There we go. And you can see the lows right here. There's the upper low forming over Virginia. Remember that? Now, the other problem is as I pointed out here in this discussion, the Pacific is completely wrong. All this energy is coming in this way. And there's another big disturbance right here, which was threatened which could kick the system off the coast. So the snowstorm never gets a chance to form. So just because the model has it doesn't mean it's the right solution. You have to look and see if the model is making sense. And in this case, it did not. So that was one of the reasons why I thought this was unlikely to happen. The net problem is that, sure enough, the European decided, I want to get in the game too here. And on the 0Z run here for, I guess this is November 7th, the European did the same thing. It had developing, the front stalled over North Carolina. It had a lot of cold air and snow in as you can see here in Virginia and into southwestern Virginia, heavy snow, and then the low is forming here, and you had heavy snow over the interior. And of course, what that looked like was a pretty big snowstorm. And that's what it was producing. I mean, that's huge. Look at that. That's enormous. And I don't know if you can see this, but that's actually 12 inches in and around Richmond, 17 inches up in Tappahannock and St. Mary's counties. I mean, it's massive. The problem is that it's not really late winter. It's autumn. You know, if this was mid-December, mid-January, okay, it's a different matter. But the ground temperatures are also very, very warm, and that would keep down the snow totals. But the models don't care about the ground temperatures that much. That's something else we have to figure out as humans that's not really in the model equations. And this was the later run of the European, and it kept doing the same sort of thing. Now, this case, the European had a little further inland. Notice the low here is now over eastern North Carolina, whereas before the low was off the coast a little bit. So that's one of the differences. And then as a result of that, the heavy snow over southwestern Virginia, up into Ohio, West Virginia, and to western Pennsylvania, up into the mountains of Pennsylvania. So that's what it was doing on the European on the 12Z run for November 7th. So it looked like we were getting some sort of indication that this was going to happen. But this is why this pattern did not happen. So let's take a look at February 7th, 2010. This was the first blizzard which hit D.C., Baltimore, and up into the Mid-Atlantic states. So this, in case you remember the storm, this is what the surface map looked like. It was the first snowgasm or snow Armageddon, whatever the idiotic, stupid phrase that the Weather Channel was using at the time. And that what the map was looking like from February 2007, 2010. This was the snow map. As you can see, it showed huge amounts of snow, upwards of 20 inches, all in this whole area, as you can see very nicely. Very impressive up in here. So we all saw that, and that was the February 7th snowstorm, and over northern Virginia, Maryland, into eastern West Virginia and Delaware, and so on and so forth. So that's what the surface map looked like. And let me show you what the actual upper air map. Now this is the upper air map of the storm. Notice the date here, okay? February 6th. You see that? So this is when the thing is going underway. We can see the 50-50 low is in place here. This is an upper low, two 500 lows, which is over southeastern Canada. And we have the P&A here. You can see the ridge coming in this way. See the ridge coming down. But we also have a split flow. We have one piece of energy coming in here, the southern stream, and then the next which comes up this way over the ridge. So there's your split flow. So a split flow is very nice to have. We have a negative NAO up in northern Canada. We can see it up in here. There was a negative NAO up in here. We can see that. And so all the features are in place. That's why this was such a big snowstorm. Now, this is let me show you, this was as of February 4th. This was 3 or 4 days earlier. Look at the date here, February 4th. You see this? Close up so we can see it. February 4th right there. Okay, so this is several days out. You could see this snowstorm coming. Again, look, 50-50 low here, negative NAO here. Look at the split flow. The Arctic jet, the polar jet coming down this way, the southern jet. There's the southern low coming this way. This had snowstorm written all over it. You could see it days and days in advance. All the pieces that you needed were in place here. So that's why this was an easy one to call. Okay, let's take a look at another event. This is February 11th, 2006, the other mid-Atlantic snowstorm, which covered everybody from Richmond up towards Boston. And you could see there's the big low off the coast. Very nice. You remember that storm. And of course, here is the upper air map from February 9th. This is 2.5 days earlier. And you can see, again, notice, let me point to these features out here. The split flow, you see the split flow? Now, again, we had one flow going like this. Okay. The other one, the southern flow going like this. See that? And here is the Arctic jet coming down even that way. Now, we also had the mean trough on the East Coast already. So that meant that what the key features here was, in this storm, which is why it was such a big snowstorm, was this feature and this feature. They were going to meet right here, which is exactly what happened. There's your negative NAO. Here's your 50-50 low in eastern Canada. We had those features in place, the split flow, the P&A ridge. It was an easy forecast to make. It was obvious that there was a major snowstorm coming for the East Coast. The pattern determines what happens, the upper air patterns, not the models. And then finally, February 10th, this is a couple days later, we can see again, very easy. There's your southern system. There's the northern branch. Okay, there's our P&A right here. See that? There's the negative NAO. There's a 50-50 low. Obvious setup for a major East Coast snowstorm. You can see the big ones coming out days and days ahead of time, folks. You really can. And we didn't see that with this one. That's why the November 13th, 14th event is not likely to happen. Interestingly enough, on the Twitter accounts here, some idiot from WSI Energy Weather comes out and says after the European bailed out on Thursday or Friday, it said that chalk went up for the GFS. Excuse me? The GFS was the first model which had the system. Are these people drunk? Anyway, some of the forecasts of some of these private vendors are just shockingly inept. Anyway, so let's talk about the next 2 weeks here. We can see this is the current map as of November 9th. We can see a very strongly Arctic oscillation, a very strong negative NAO. The EPO is neutral right here, and we have a pretty zonal flow. And that's the actual upper air map as of today. Also notice is one other feature here. We have a huge vortex over Japan and eastern Siberia and the Bering Sea as well. So overall, not a great pattern for early winter weather, but again, it's mid-November. That's not a huge deal. If we look at the MJO, all the models are showing very weak conditions in the MJO. They all keep it pretty much in the circle of death in here. You can see that. That's pretty much, you know, a given. And then if we go to the next one, these are the folks from Albany, and what they show is the MJO doing very nicely here, coming out and then moving into the circle of death almost and becoming neutral. And again, this is the circle of death, the neutral zone. So the MJO is having no impact, okay? No impact, NI, negative impact over the pattern for the next 2 weeks. That's what I'm trying to get across here, because it's essentially dead. It's in the neutral zone. So that means you can look at other features here. Now look at this Arctic oscillation. I mean, goodness gracious here. Here's the AO, okay? It's so far positive, it's all the way up here, it's off the chart. Now it does drop down towards Thanksgiving here a little bit towards neutral, and this here's the NAO, which is positive, and then it drops down towards neutral towards Thanksgiving. So that's a little better. At least it's not super positive anymore. Let me clear this out. And this here's the EPO, and the EPO is very negative, and then it goes neutral, then slightly positive here. And the P&A is playing a game up and down as the different waves move from the Pacific. First it's down, then it's neutral, then it's down, then it's neutral, as different energies coming in from the Pacific Ocean. This here is our upper air map for Tuesday, November 12th. We can see the very nice features here. Now, we appear to have a P&A pattern here, but it's brief. It's transitory. It doesn't last. And let me show you so you can see it. There's our ridge. See our ridge right here? Okay, so there's our cold air coming southward. There's the Arctic front. Okay, and we'll see that on the map right here. There's the other ridge out here in the Bering Sea. But notice up here, this is Arctic oscillation. That's positive. NAO. That's positive. No split flow at all. There's no southern stream energy here at all. Very, very much of a problem, which is one of the reasons why the storm doesn't develop. Here's the Arctic front coming south. Okay, very nice. Here's the enormous Arctic high right there. See, it's like 1045 millibars. Here's the Arctic front. Whoosh. Tremendous cold air coming in here. Very impressive cold air for this time of year. And that's indicative of the amount of cold air which is building up in Canada. And that's continuing. So that's a good sign long term. And then this low forms, as you can see, the low forms right here off the coast. The high is now losing its intensity. The flow is going this way. So the supply of cold air gets cut off and it begins to moderate, as you can see. And then if we look, this is the 120 hours, November 14th. This here is the upper low, the remains of it. Instead of that big upper low forming over here, it's now a weak little system here. The flow is going, look at the jet coming in this way. My God. Woo! That's a stiff jet. Piece of energy here, another one here. And again, the Arctic oscillation, very positive, as you can see. And the NAO as well. Very positive NAO, as you can see. So that's how the pattern's looking at to day 5. And we go beyond that. This is the European here for day 8. And you can see the trough coming in very nicely right here. Look at the ridge developing there and the southwest flow. So again, some patterning up here as we go towards the 30. And this is day 9, the European and the GFS. You can see the European is here. The GFS is there. They both have the southeast ridge, right? They both have the trough here. See that? Look at the huge positive anomaly in the northern Pacific, which is pushing. This connects to that. That's why you're having it there. So again, not much changes here in the pattern. And then in day 10-9, we have a big system coming into the Midwest. As you can see, it very mild here. Look at the warm area over the eastern half of the United States. And then that becomes a huge storm here day 10 on November 19th for the upper Midwest. Could be a blizzard up there. And then if you even go beyond that, 360 hours out, we're beginning to see a little bit of blocking up or building heights in Canada and a little bit of ridging over western United States. It's not a big change, but it's a step in the right direction towards a more seasonal cold pattern. Anyway, that's the analysis and the forecast. Hopefully you've learned something. This is meteorologist DT from weatherist.com. I'll talk to you soon.